Lack of potable water globally causes significant economic harm. Some 2.2 billion people around the world do not have safely managed drinking water, while 4.2 billion go without safe sanitation services and 3 billion lack basic handwashing facilities, according to a new report from the United Nations Children's Fund and the World Health Organization. Inadequate water and sanitation in developing countries cost 5% of their GDP, and up to 10% in some countries, according to the UN. A study by the Water Project showed 160 million hours of lost labor in Africa alone due to water scarcity. The World Bank estimates that the cost of water scarcity could reach $14 billion annually by 2030 and cause food shortages and political instability. The water potability problem refers to the issue of determining if water is safe for human consumption. Basic water potability indicators include tests for coliform bacteria, nitrates, pH, sodium, chloride, fluoride, sulfate, iron, manganese, total dissolved solids, and hardness. Identifying water potability estimation using deep neural networks includes gathering labeled data, training a network using a deep learning framework with input features of water samples, output potability predictions, and evaluating performance on test data. Identifying water potability is a complex task, but deep neural networks trained on large datasets have achieved accuracy rates of up to 95%. AITS engineers have developed a low-code platform with templates to potability prediction of water using AI computer vision techniques and machine learning algorithms. A TinyML platform like cAInvas using deep neural networks has been shown to improve the accuracy of water potability tests by up to 10% compared to traditional methods. In studies, these models have achieved accuracy rates as high as 95% when trained on large and diverse datasets of over 10,000 water samples. The use of additional features, such as pH level, temperature, and turbidity, can further improve the accuracy of the model. The deep learning model is easily created by collecting sensor-fused features from potable and dirty water samples in a dataset on a TinyML platform like cAInvas with pre-processing that includes normalization and augmentation, and training the model resulting in an accurate model that is compiled with DeepC. The resulting application is ported to a TinyML device connected with a microphone that is mobile enough to run on batteries and with no internet connection in remote areas, so you can easily carry it in your pocket to identify the potability of water in remote areas yourself or help neighbors and friends from falling sick. Following URLs are referred to in this video. Check the description for the links. Contact us.